Module 9, Chapter 7.1, Systems of Equations. Recall a linear equation in two variables has the form ax plus by equals c, where a, b, and c are real numbers. We say each of the variables are of first degree because there are no powers on the variables x and y. We can extend this idea to more variables. A linear equation in n unknowns or n variables has the form a1x1 plus a2x2 plus all the way up to anxn equals b, where the variables x are each of first degree. A set of equations is called a system of equations. The solution or solutions to a system of equations must satisfy each equation in the system. A linear equation in n unknowns has the form a1x1 plus all the way up to anxn, where the variables are of first degree. And actually, because it's an equation, we would say it's equal to some number. If all equations in a system are linear, the system is a system of linear equations, or sometimes we'll just call it a linear system. Now, when we solve a linear system in two variables, and we solve by the graphing method, there are three possible graphs that we may come up with. The first one is if you graph the first equation and then you graph the second equation, the point where the two lines intersect, that is your solution. So that's this case 1. Case 2 is sometimes we will graph and the lines will be parallel. In that case, there's no solution in common, so there is no solution. And the third case is we may graph the purple line, and then when we graph the blue line, it sits right on top of the first line. And in that case, the lines are actually the same line, and we say that there are many solutions. Now, real quick, one more time. If the lines graphed intersect, then there is one solution, and the solution is the ordered pair where the lines intersect. Now remember, the ordered pair must work in both equations in the system to be a solution. If the lines are parallel, then there is no solution, and we say that the system is inconsistent. Third case, if the lines are actually the same line, then the system has many solutions. We say that the equations are dependent, and many solution means any solution that works in one equation will also work in the second equation. Now, we're going to talk about several methods for solving systems of linear equations in two variables. The graphing method, which we've talked about, the substitution method, and the elimination method. The graphing method involves looking at the graphs of both equations and recognizing that the point where they intersect is the solution to the system. Now, these graphs sometimes will take a long time to graph, and also it's hard to tell exactly where they intersect if you're doing pencil paper method. You can use your calculator to find the intersection of the graph. And as a note, the equations must be in y equal form in order to be entered into the calculator. Okay, so if we wanted to solve the system using our calculator, 3x plus 2y equals 11 and negative x plus y equals 3. The first thing we have to do is get both equations in y equals form. So 3x plus 2y equals 11. Subtract 3x from both sides and we get negative 3x plus 11. Divide both sides by 2 and we get y equals negative 3x plus 11 divided by 2. This is what we're going to call y1. y2, the second equation, negative x plus y equals 3. We're going to add x to both sides, so y equals x plus 3. This is what we're going to enter in our calculator as y2. Okay, so to enter this, make sure on the first one, because we have a fraction, that we separate the top and the bottom with parentheses. So we're going to say in parentheses, negative 3x plus 11 divided by 2. The second one, we get y equals x plus 3. Graph those. Both of those are linear equations, so both graphs will be straight lines. The point where they intersect will be the solution. To find that, we're going to go second, calculate number 5, enter, 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 and we get a solution of x is 1, y is 4. Now to check these, we're going to go back, plug in x is 1, y is 4, 3 times 1 is 3, 2 times 4 is 8, 3 plus 8 is 11. That one checks. Second one, x is 1, y is 4, so we get negative 1 plus 4, which is 3, which is what we were supposed to, so we know that our solution is good. Now the second method, the substitution method, involves substituting an expression representing the first equation into the second equation. Solving this new equation will give you the value of one of the variables. Substitute this value back into the expression found in the first step, and this will give you the value of the second variable. Some more specific steps. Solve either equation for either variable. That is, get either equation in x equals or y equals form. My advice is go ahead and circle it because we're going to use that in the last step. Number 2, substitute the expression found in step 1 into the other equation in place of the variable solved for. So if we've solved for x equal in the first one, we're going to plug it into the other in place of x. Step number 3, solve this. Step number 4, substitute the value found in step 3 into the expression found in step 1, the circled equation, and then we're going to solve this. And then we always go back and write our solution in ordered pair form. So for example, if we have y equals 2x plus 1 and negative x plus y equals 3, notice we've already got the top equation in y equals form. So what we do is we go into the other equation. Everywhere we had a y, we're going to plug in 2x plus 1. Okay? Y is the same as 2x plus 1. So go into the second equation, but instead of calling it y, we're going to call it 2x plus 1. Everything else stays the same. So we get negative x plus 2x plus 1 equals 3, x plus 1 equals 3, or x is 2. Now, don't quit yet. We've got to have the complete ordered pair. So if x is 2, to find y, we go back to our circled equation. Y equals 2 times x, but x is 2 plus 1. So y equals 4 plus 1, or 5. So what we're saying is that the ordered pair solution is 2, 5. Let's check it. If we check x is 2, y is 5, we get 2 times 2 is 4. 4 plus 1 is 5. It checked here, and it has to check in the second one. If x is 2 and y is 5, this becomes negative 2 plus 5, which is 3. It checks here, so our solution is 2, 5. Let's do another one. Solve by the substitution method. Now this one's a little different because we do not have x equals or y equals. But we can choose either this x or this y, and because this is a positive y, I think this one may be easier. So what we're going to do is we're going to add x to both sides, so we get y equals x plus 3. this becomes our circled equation. So now we go into the other equation. Everywhere we had a y, we're going to plug in what y is equal to. So we get 3x plus 2 times y, but y is now x plus 3 equals 11. So we get 3x plus 2x plus 6 equals 11. 5x plus 6 equals 11. Subtract 6, so 5x is equal to 5, or x is 1. Don't quit. Remember, we've got to have an ordered pair. So we take that and we plug it back into our circled equation. Y equals 1 plus 3, so y equals 4. So our solution would be 1, 4. Let's check it. If x is 1, y is 4, 3 times 1 is 3, 2 times 4 is 8, 3 plus 8 is 11. For the second one, if x is 1, y is 4, we get negative 1 plus 4, which is 3. So that one checks also. So the solution to the system is x is 1, y is 4. Now the third method is the elimination method, or sometimes they call it the addition method. This method uses the fact that you can add the same quantity to both sides of an equation without changing the solution set. Now, some specific steps for this method. First thing is you want to write both equations in standard form, meaning get the x's and y's on one side, the numbers on the other side. Second step, if necessary, multiply one or both equations by some number so that the coefficients of x or y are opposites of each other. Then, once you have opposites, add those two equations together, solve that, substitute the value you get here into either one of the original equations. Solving that will give you the second value, and then you write the solution in ordered pair form. Okay, so solve this system using the elimination method. We've already got standard form. X's and y's are on both sides. Now x's, we've got 3x and 2x. Those are not opposites. On y's, we've got negative 3y and positive 3y. We already have opposites, so we're going to go to the next step. The next step says add these up. 3x plus 2x is 5x. 3y negative 3y, those cancel. And then 6 plus 14 is 20. Well, if 5x is equal to 20, dividing both sides by 5 gives us x is equal to 4. If x is 4, go back into either original. I'll just go back to the first one. 3 times 4 minus 3y equals 6. 12 minus 3y equals 6. Minus 12 minus 12, so we get negative 3y equals negative 6. So y is 2. So it looks like our solution in ordered pair form is x is 4, y is 2. Let's check it. X is 4, y is 2. That's 12 minus 6 is 6. X is 4, y is 2. That is 8 plus 6, which is 14. So our solution would be 4, 2. Now, let's do another one. Solve the system using elimination method. We want opposites. Now, if we look at x's, we've got 3x and negative 1x. Now, opposites doesn't just mean one's a positive, one's a negative, but it means they're of opposite signs of the same number. Of the y's, we've got 2y and 1y. Those are not opposites. So our first question is, do we want to try and get opposite x's or opposite y's? And if that confuses you, just always go and get opposite x's. So if this is a 3x, we would need this to be a negative 3x. Well, if we've got the negative x, that means all we need to do is multiply by 3. And when we do that, we do both sides of the equation by 3. So what that gives us is 3x plus 2y equals 11. The second one, we get negative 3x plus 3y equals 9. Don't forget the second side. Now we've got x opposites. So when we add them, 2x plus 3y would give us 5y. 11 plus 9 is 20. Dividing by 5 gives us y is equal to 4. Now we're going to take y as 4 and plug it back into either original. This time we can go to the second one. We'd get negative x plus 4 equals 3. Minus 4 on both sides gives us negative x is negative 1. So x is 1. So our solution would be x is 1, y is 4. Let's check it. X is 1, y is 4. 3 plus 8 is 11. 1, 4. Negative 1 plus 4 is 3. So our solution would be 1, 4. Now, do you remember the three cases represented by the graphing method? Now, how do these relate to the substitution and elimination methods? Well, if we have a no solution or a mini solution, let's look to see what would happen if we were working those by substitution or elimination. Solve this system. Well, because we've got x's and y's already on the same side, probably best bet would be elimination. We need opposites, so if we want to do opposite x's, this is a negative 6, this is a positive 3. So the at least common multiple for 6 and 3 is 6. So we say, okay, let's do opposite 6's. Well, here's a negative 6. So up here we need a positive 6x. If we already had a 3, that means we're going to multiply the whole top equation by 2. So that would give us 6x minus 4y equals 8. The bottom one gives us negative 6x plus 4y equals 7. Now in this case, the x's cancel, the y's cancel, but the numbers don't. So what that says is 0 is equal to 15. The way we can interpret that is it doesn't matter what x and y are, the left side will never equal the right side. Therefore, there is no solution. And if we would have graphed that, we would have gotten two graphs that were parallel lines. Okay, let's do another one. Now this one, even though we've already got standard form, let's try substitution method on this one. This y right here would probably be a good one to solve for. So we're going to go through and add 4x to both sides. So we get y equals 4x plus 2. Now this is what we're going to substitute into the other equation in place of y. So we would get 8x minus 2 times y, but we just said y was 4x plus 2 equals negative 4. Now if we distribute that negative 2, that gives us negative 8x minus 4 equals negative 4. Combining like terms, 8x minus 8x, that cancels. Okay, same thing as earlier. If your x's and y's cancel, but now see this time the result is true, negative 4 equals negative 4. In that case, we say that there are many solutions. Now occasionally on this what they'll do is they'll say, then the solution set is the ordered pair x, y, where negative 4x plus y equals 2. And what that means is the solution is all ordered pairs that work in either of the equations. Okay, now, what if the equations are not linear? A nonlinear system of equations is a system in which at least one of the equations is not a linear equation. So if we wanted to solve this system by graphing, y equals 2 to the x, and the absolute value of x plus 2 minus y equals 0. Well, the first thing we've got to do is get both equations in y equals form. first equation is good. So y1 is going to be y equals 2 to the x. The second equation, I think what I'm just going to add y to both sides. So our second equation would be y is equal to the absolute value of x plus 2. So if we're doing this one on our calculator, y1 is 2 to the power of x. y2 is the absolute value. Remember, that is math, slide to number. Option number 1 is absolute value of x plus 2. Graph that. Remember, absolute value is a V-shaped graph. Our 2 to the x is our exponential function, which is our little curve. So what it appears is we've got two solutions, one here, one here. Second, calculate where they intersect. Enter, enter, enter. Okay, so that gives us a solution of negative 1.69 and 0.31. Now we're going to see if we can find the other one. Second, calculate number 5, enter, enter. Let's move our cursor up closer to the other one. And the second solution would be x is 2, y is 4. Okay, now let's solve this system by substitution. And the only requirement in substitution is that you get an x or a y on one side by itself. There's an x squared. This is a negative 2y. This looks like a good one because there's nothing with that x. So what we're going to do is subtract 3y from both sides, and we get x equals negative 3y minus 4. This is what we're going to use for the substitution. So we're going to come up into this equation. Everywhere we had an x, we're going to plug in negative 3y minus 4. So we get 3 times negative 3y minus 4 squared minus 2y equals 5. Well, now here we've got a binomial squared, so we're going to have to FOIL it out. First 2 would give us a positive 9y squared. Outer 2 would give us a positive 12y. Inner 2 would give us a positive 12y. And the last 2 would give us a positive 16 minus 2y equals 5. Okay, now when we go through, let's simplify a little bit. We've got 9y squared plus 24y plus 16 minus 2y equals 5. Now distributing by 3, we get 27y squared plus 72y plus 48 minus 2y equals 5. Now this is quadratic. So to solve a quadratic, we set it equal to 0. So combine like terms, so we get 27y squared plus 70y. Go ahead, subtract 5 from both sides, so we get plus 43 is equal to 0. Then we're going to factor, or see if it'll factor. Now in this one, we know that the first 2 have to multiply to give you 27y squared. Well, I'm going to try 27y and y. We know signs are both the same and they're both positive. The last 2 have to multiply to give you 43, so we'll do 43 and 1. That would give us 27y squared. 27y and 43y gives us 70y. Last 2 are 43. Then we're going to set each of those equal to 0. 27y plus 43 equals 0, and y plus 1 equals 0. Well, the first case, subtract 43 from both sides. Divide by 27, so we get negative 43 over 27. The second case, subtracting 1, and we get y equals negative 1. Now notice, these are just the y values for the 2 ordered pairs. So what we're going to do is we're going to take each of these y values and plug them back in to find the x values. So that's negative 3 times negative 1 minus 4, which is 3 minus 4. So the first ordered pair is x is negative 1, y is negative 1. The second ordered pair, well, we know the y value, so we plug it in, we get negative 3 times negative 43 over 27 minus 4. Well, negative 3 and 27 will cancel 1, 9. So a negative 1 times 43 would be 43 over 9 minus 4, but remember 4 is the same as 36 over 9, which would give us 7 over 9. So our second ordered pair would be x is 7/9, and the y value would be negative 43 over 27. Now, depending on if they want your answer in fraction or decimal form, you may have to put that in the calculator to get a decimal value. Now, let's solve this system by elimination. Now, luckily, we've got x squareds in both columns and y squareds in both columns. Well, notice we've already got opposite y squareds, so we're just going to add the two equations together. 1x squared plus 2x squared gives us 3x squared. Y's cancel equals 27. Well, we can divide both sides by 3, so x squared is equal to 9. The square root property says square root both sides. Give one side plus or minus, so our answer would be plus or minus 3. Okay, now because there's two variables here, we know that x is 3 and x is negative 3. We've got to plug that in and get the y value. So we can go to either of the originals. We'll get the same answer whichever one we go to. So if we take x is 3 and plug it in the first one, we get 3 squared plus y squared equals 10. 9 plus y squared equals 10. Subtracting 9 from both sides, we get y squared equals 1. So y is equal to plus or minus the square root of 1, which is plus or minus 1. So what we get is x is 3, y is 1, or x is 3, y is negative 1. Then when we do the same for negative 3, we would get negative 3 squared plus y squared equals 10. 9 plus y squared equals 10. Subtracting 9, so we get y squared equals 1. So y equals plus or minus 1. So we've got negative 3, comma 1, and we've got negative 3, negative 1. So in this case, we're actually going to have 4 ordered pairs that are solutions to this system. Now you're ready to complete this section of homework on my math lab.